Hello, and for this video we're just going to go through the bar model shown on the sheet that you got given for your homework this week. Hopefully this will help you to understand the bar model, use it in future and use it to solve these problems. So the first sheet that we're going to look at is the one about the fish shop. So we know the prices of all the items and we know how much money the person's got. So with the bar model we try and take every piece of information we have and represent it with a bar. So I'm going to start with the fish that he buys. So I'm going to draw my bar for the fish. That cost me 195 pence. Okay. He also buys some peas. So next to the bar for the fish I'm going to draw my bar for the peas. 38 pence. And he also buys 2 large bags of chips. So we've got a 70p and another 70p. When I add all of these together, that will tell me how much money he has to spend in the shop to buy all those things. We don't yet know that, but we'll work it out by using column addition. Luke has got £3. How much more money does he need? So his £3 is how much money he has got. The how much more part we don't know is at the end here. This is the unknown part. So once we've worked out the total price, which will go here, we will then have the total price of his fish and chips and his mushy peas, and we'll have £3. We need to find the difference, and the way we find the difference is by taking the larger amount and subtracting 3 from it. So that's the bar model explained for this problem. Hopefully now you can go away and work out the answer. So we've got a different problem this time, so we'll read it through, and every piece of information we've got we'll try and represent using the bar model. Now I notice straight away that we've got litres and millilitres in the same problem. When you've got a mixture of units like this, it makes sense to use just one unit of measurement. So we're going to convert the litres into millilitres, because it's normally easier to work with whole numbers and millilitres rather than using decimal numbers. So I know that 1 litre of lemonade is 1,000 millilitres. So I'm going to draw my bottle. This is my bottle of lemonade with 1,000 millilitres in it. Rachel's filling 5 glasses with lemonade and she puts 150 millilitres in each glass. So I'm going to draw those glasses. So I've got 150 in here, 150 in the second glass, in the third glass, in the fourth glass, and then the fifth glass. And there is some left in the bottle. Okay. So I'm going to try and put 150 into each glass. So now we can see the problem. We can see we've got the whole bottle of lemonade at the top. We've got 1, 2, 3, 4, 5 glasses, and this bar represents the amount that's left in the bottle at the end. So you should see now from the bar model that any numbers that are side by side, we should be able to add them together. Okay. So we can add together all the 150s, all do 150 times by 5. The answer to that will go in the bar underneath here. And we already know from finding the difference on the previous question, we take the 1,000 millilitres, subtract this bar here, and that will give us our answer. We can then add this bar to this bar together, and that should give us 1,000 because they are the same size as the 1,000 bar. If we don't have 1,000 after adding these two numbers together, something has gone wrong in our problem and we need to check our answer and recalculate. Now this is a slightly more confusing sounding problem when you read it through first of all, but once we use the bar model hopefully it will become very clear. We've got K, M and N each standing for a whole number. They add together to make 1,500. So I'm going to draw that problem to help me understand what's going on before I go any further. So I know that they all make 1,500, and then we've got K, we've got M, and we've got N underneath. So we've got K, try and draw it properly, we have K, we have an M and an N, and they make 1,500. Okay. So you might think if you don't go any further that we could have 500 in each, and that's the problem solved. But we have extra clues underneath, which is where it gets more complicated. So I'm going to make a note of my N, I've got my M, I've got my K here. Okay. I know that M is 3 times as big as N. So if I represent N with 1 bar, M is 3 times bigger. So it's the same equivalent bar, so they're next to each other. Now I've got another one. Now M is now 3 times bigger than N. Okay. So I read my next clue. K is twice as big as N. So if N is represented by 1 bar, K will be represented by 2 bars. And I know that all of these, when I add them together, will make 1,500. I still don't have a solution to the problem. But when I look at my bar model, I think, well, I've now got 1, 2, 3, 4, 5, 6 blocks make 1,500. So if I drew a different bar model, and I drew it this way around, 1, 2, 3, 4, 5, 6 blocks make 1,500. So now I can see that my 1,500 has been split into 6 pieces. So 1,500 divided by 6. But then you can obviously, when you put the numbers in there, check your answer again. So hopefully you can see that this is a way of taking that bar model, representing each part of the problem at a time, and turning quite a complicated problem into a relatively simple calculation. The bar model helps us to visualise what's going on, and in this case we've maybe had to draw a few different bar models. We've actually drawn 1, 2, 3 bar models to help us, but we've ended up with hopefully the right answer. Right, this is a bar model involving fractions. We've got 3/4 of a number. We don't know what that number is, but we know that 3/4 of it is 48. So I'm going to draw my bar model. Okay. That's the whole object that I'm representing. That is the number. I don't know what that number is, but I do know it's divided into quarters. So I try and divide it into 4 even sections. Now 3/4 of it is 48. So if 3/4 are 48, I should be able to split 48 up 3 ways to get the answer in each one of these boxes. And because they're equal quarters, whatever number ends up in this box will also be in this box, will also be in this box, will also be in this box. And when I've done that, I will have 4 identical numbers. And because they're side by side, I'll just need to add them up or times this one by 4. And that will give me the answer there. So again, a quite complicated sounding question, made relatively simple with the bar model. To finish, perhaps the simplest one of the lot, we have got 3/8 of 980. So we have got my 980, and it's eighths, so I need to divide it into 8 pieces. And I want 3/8. So first of all, I will need to divide 980 by 8. That will give me each box. And because I've got just 3 of them, I would add these 3 together to give me my answer. That would be 3/8. Okay? And there will be 5/8 left over. So hopefully now you've seen the videos alongside the bar model, it helps you to understand how it can be used to solve the problems. You still obviously have to do the calculation methods, but the bar model visualises the problems for you. The next few weeks you'll be getting a similar sheet, which will have the bar models drawn for you. Then hopefully we're going to move on to not having the bar model there and you drawing the bar model yourself to solve these problems. It takes a few seconds to draw the bar model, but it can save you time in the long run because it helps you understand the problem and get the correct answer, and importantly to check your answer at the end.